Assalamu alaikum. The topic that we're going to be covering today is a distance time graph. So let's look at the objectives for today's lesson. So our aims for today's lesson is to show speed as a graph, to show the distance that is covered by an object against its time as a graph. Next is to identify the graphs showing constant and changing speed. And then when we can easily identify that which graph is representing constant speed, which graph is representing increasing speed or decreasing speed, which graph is representing when the object is stationary and actually not moving at all, then by looking at the graph, by using the graph, we will calculate the speed, distance, and time at points on the graph. So first, let's move on to the representation of distance on a distance time graph. So when we are representing distance on a distance time graph, we have two axes, that is the x-axis and the y-axis. On the x-axis, you always have the independent quantity. The independent quantity is the one that you cannot control. So here the independent quantity that cannot be controlled is the time. And the unit for time would be second, which is the SI unit. And on the y-axis, we usually have the dependent quantity, which in this case would be the distance given in meters. Okay, so your x-axis would have time and your y-axis would have distance. You are going to calibrate your x-axis and your y-axis according to the requirement of the question. Since right now we're talking generally, so I'm not calibrating or marking the x-axis or the y-axis. Okay. Now the first thing that we should learn to represent on a graph is when the object is stationary. Okay, when your object is not moving. Let's assume that we have a car here. Okay, this car initially covered a distance of 1 meters. Okay, initially the car covered a distance of 0 to 1 meter. And when the car came to this point, which is the 1 meter point, at this point, the car stopped. And now it's not moving. So when your car is not further moving, remember this means that your car is not covering any more distance. Initially it covered 1 meter, but now it is not covering any more distance. So let's suppose if I calibrate the y-axis distance and if 1 meter marking was right here, 1 meter. And if I try to plot this situation on the graph, I know that at time t is equal to 0, my car was at a mark of 1 meter right here. Then as time elapsed, let's say 10 seconds elapsed, and my car is still at 1 meter point. After 20 seconds, it's still at 1 meter point. After 30 seconds, it would still be at 1 meter point because it is not covering any more distance. That means an object that is showing 0 movement or that is stationary or is at rest will be represented using a horizontal line on the x-axis. Okay, a horizontal line that is parallel to the x-axis on a distance time graph shows an object that is not moving. Okay, an object that is stationary. Now, if you want to have a clear picture, so moving forward, a no movement object would have a straight line. Now, that straight line not necessarily needs to be at the axis. Let's suppose if your car initially was at a mark of 30 kilometers, okay, then you're going to have a straight line here. If your car was at a mark of 50 kilometers, you're going to have a straight line starting from here. So what you need to remember is a horizontal straight line parallel to the x-axis on the distance time graph represents when the object is at rest or the object is stationary. I hope this is clear. So moving on, the next that we have is when the object is moving at a constant speed. Now, when we say that the object is moving at a constant speed, what does constant speed means? So constant speed, if I write it in terms of English language, we say constant speed is when an object covers equal distance in equal time. Okay, equal distance in equal time. This is what constant speed means. Okay, equal distance s in equal time t. This is what constant speed is. So that means, let's suppose if we start from 0 and I say that during the first 5 seconds, my car covers a distance of 10 meters. Then again, during the next 5 seconds, that would be 10 seconds, my car should again cover a distance of 10 meters and it should be at 20 meters. And since this is constant speed and my car is covering equal distance in equal intervals of time, so at 15 seconds, it should again have covered 10 more meters and it should be here at 30 meters. So if you keep on doing that, you would see that you come across a straight slanting line. Okay, a straight slanting line represents constant speed. A straight slanting line on the distance time graph represents constant speed or uniform speed or constant velocity because this is representing equal distance covered in equal amount of time. Got it? So now, if you move forward, so a slanting straight line represents a constant speed. Now there's a little question, and the question is that how would the graph look for a faster constant speed? Now, what is that supposed to mean? That's supposed to mean, let's suppose if this object, the blue line, was traveling at a speed of 40 meters per second, meters per second, which is the unit of speed. What kind of a line I would have for an object that is traveling at 70 meters per second? Or I could also think of what kind of a line I would have for an object that is traveling at a constant speed of, let's say, 15 meters per second. So the faster the speed is, the steeper will be your graph. The faster the speed is, the steeper will be your graph. So for a 70 meter speed, we would again have a straight line, but it would be steeper than the blue one. And for a 15 meters per second speed, since this is less as compared to 40 and 70, again, we're going to have a straight line, but it would be less steeper as compared to the other two. So the steeper the slope, the faster is the speed, but that does not mean that the speed is varying or changing. It just means that it is traveling at a faster constant speed. This point could be summarized if we look at this slide. So the green line here, the dotted one, represents an object that is traveling at a constant speed, but a faster one, since the slope is steep. And how would the graph look for a slower constant speed? It would look something like this. Here you can see that the slope of the line is less, or the line is less steeper. Okay. Now, another thing, in case of distance time graph, we know the lines are representing the constant speed, but can we actually calculate the value of that speed? And the answer is absolutely yes. Although this is a distance time graph, but if we calculate the gradient of the graph, that would give us the speed. For those of you who are unclear as to what gradient is when we calculate the slope of the line. So slope which is also called gradient, is basically the change of distance on y-axis. So it is change of distance on y-axis divided by change of value on x-axis. Now, if you look at the y-axis in this particular example, you know that the y-axis is basically representing distance. So the change in value would also represent distance here. Whereas the x-axis in this particular example is representing time, and the change on any of value on x-axis would also represent time. Now, if you focus on this equation of distance over time, what is this value? We've already studied it so many times. What this formula, if you can remember this formula, this is basically the formula to calculate the speed or velocity, as speed or velocity is equal to distance over time. S over T is equal to V. Okay, so this is the formula for speed. Now, how do we calculate the gradient on a graph? What is the actual formula by using the graph to calculate the speed using a distance time graph? We've proven here that the slope is actually the speed. Okay, but how to do that? So what we need to do is that we need to consider any 2 points on the slope. So consider any 2 points on the slope. Let's, for understanding's sake, assume that this is representing 15 seconds. This is 10, 5, and 0. And this is representing 2 and 4. Okay, so I have selected any 2 points on my graph. This one would be my point 2, which I would call as x2, y2, which is the common representation of a point on a graph. So my x2 value corresponds to 15, whereas my y2 value corresponds to 4. Now let's come to the other point. This point would be my point 1, and I would call it as x1, y1, where x1 is basically 10 and y1 corresponds to a value of 2. Now, in order to calculate the slope or the gradient, the formula that we use is change in y values, that is y2 minus y1. This y2 minus y1 is basically giving us this distance, change in y values, divided by change in x values, that is x2 minus x1, which is basically giving us this value. So putting in the values, 4 minus 2 divided by 15 minus 10. That is 2 over 5. Now 2 here is basically meters because on y-axis we've got distance, and 5 here is basically seconds because on x-axis we've got time. So 2 divided by 5, that would be 0.4 meters per second, where 0.4 meters per second is the speed of the object, which is represented using the blue graph. So this is how, using a slope formula, you can calculate a constant speed of an object by looking at its distance time graph. Okay, moving forward, let's clear the screen here. Moving forward, what if our object is not traveling at a constant speed? What if our object is speeding up, or if it is slowing down? Like you're traveling in a car and you press on your gas pedal or your accelerator, so the speed of your car would increase, okay? Or if you're hitting a red light, you press the brake and the speed of your car would decrease. How do we represent increasing speeds or decreasing speeds on a distance time graph? So for an increasing speed, the distance time graph would not be a straight slanting line, rather it would be an increasing curve, something like this. Okay, and if you look at this increasing curve, you can see that as the time increases, the distance is not increasing by equal amounts. That means that your car is speeding up and you're covering more distance in less time. Okay, so an increasing curve represents acceleration. An increasing curve on the distance time graph represents acceleration. I hope this is clear. Now let's have a clear picture to go with it of an increasing curve. So your graph would look something like this. And here you can clearly see that the distance is not increasing equally by equal intervals of time. Rather, as the speed increases, more distance is covered in less amount of time. So this is how you represent acceleration on distance time graph. Okay, now let's look at this example. So we have a car that is accelerating from stop and then it hits a wall. Okay, so a car accelerating from stop, that means initially at time t is equal to 0, the distance covered by the car is 0, the time is 0 because it is accelerating from stop. Now since, sorry, pardon. Now since it is accelerating, it means that we're going to have an increasing curve. And as soon as it hits the wall, let's assume that this is the point when it hits the wall. As soon as it will hit the wall, that means it would stop moving. It would stop covering more distance. And we know that when a car stops covering more distance, it is represented by a horizontal line on a distance time graph. So we would have a graph something like this. Let's have a clear picture of the graph. So our graph would be something like this. Initially, it is accelerating, and as soon as it hits the wall right about here, it stops covering more distance. It stops covering more distance, and the straight line represents that fact that it is now stationary, it's not moving, and there's no extra distance that's being covered. So, thank you. This is all at this point.